Hello, everyone. It's lovely to see you all on this summer day. I see some people that have been with us before. I see some that requested information about our program. I will not name names, not to put you on the spot, but I recognize you here, and I very much appreciate you being here. So thank you. As usual, before we start at 7 o'clock, we typically ask about where you're from, what brings you here, what's the weather like. So it's a little bit of a 3-minute chat beforehand. Today's webinar is being held by Mr. Grigoriy Khvatskiy. So I am in the background answering your questions. So feel free to ask any questions you want in the chat or through the Q&A window. So welcome everyone, and it's delightful to see you all here. And Grisha looks all serious. Yeah, he is.
Yeah.
He's preparing, even though this is not his first webinar.
Well, it's my first. I mean, it's the first webinar that I do alone.
Solo. Yeah. Yep. Well, you're not solo. We're still here. And
yeah, thank you for your support.
Of course. Well, you have a lovely topic. I knew this, but I was still surprised to realize that 95% of data that we use on a regular basis is text data. So text analytics or natural language processing, and there are many different names for similar methods. They're not the same, they're similar. They have taken off in the last 10 years or so, but we have used text analysis for many, many years prior to that. So it's actually text analysis becoming increasingly important. I was the last person probably in the lab that has given in and said, okay, finally, I will learn text analysis, because I thought just doing good analytics with numbers is enough. It is no longer enough. You have to know how to analyze texts. You have to know how to extract meaning from texts. And you have to know how to combine texts with numbers. So text analytics is becoming increasingly important, and it is a big part of our program. In many of our courses, we will be introducing, of course, we have text analytics courses, but we will be introducing topics that help people analyze data, including textual data, as part of their regular analysis. So it's about time to start. It's 7 o'clock. So again, welcome everyone. And we are delightful that you are joining us here for today's webinar. Our today's speaker is Mr. Grigoriy Khvatskiy. He is a junior researcher at the International Laboratory for Applied Network Research. He is also a PhD student at HEC University. He is a graduate of our program. So he was one of the first to finish it very successfully. By the way, former sociologist, now I don't want to use the term data scientist because it confuses people, but he is a very good data scientist, and he is tuning his skills to work on his current dissertation. My name is Valentina Kuskova. I'm the academic supervisor of the program. Many of you know me. Today, I remain in the background answering your questions. So you're welcome to ask any questions about the program, about the presentation that Grigoriy is doing. And I will be moderating those questions and asking them and helping Grigoriy answer them when the time comes. So welcome everyone. And without any further ado, Grigoriy, the floor is yours.
Yeah. Thank you. I am not sure that I'm willing to call myself a data scientist. At least for me, the name data scientist invokes living somewhere in Silicon Valley and driving a Tesla, and I am not living in Silicon Valley, and I'm not driving a Tesla, so at least not yet. So that title will probably have to wait. Now, let's actually start our webinar. So today, what is on the agenda? What we'll start with, we will start with a little bit of a discussion on what actually is our program, what it's about, what separates it and distincts it from all other such programs on data science, on data analysis, and all other online programs on Coursera. We will discuss how we approach our problems, how we solve them, and then I'll also try to demonstrate this approach in practice by using sentiment analysis to analyze some tweets that we have downloaded from Twitter. So let's start. And let's start with the 0th point, as we call it, and that's our introduction. So who am I? I think that Dr. Khvatskiy did a very good job introducing myself, but I will kind of repeat that all over again. So currently I work as a junior research fellow at the International Laboratory for Applied Network Research. And this is the part of HEC University, Higher School of Economics, that actually implements both of our programs, MASNA and MDNA. We'll talk about them both later. I currently also am an assistant director at the Center of Decision-Making Analytical Support. So I also do business analytics when I have time. And last but not least, I'm also the deputy academic supervisor of the MASNA program. Now, it kind of says this here. So I'm a computational network social scientist and analyst. And what does that mean? Well, it basically means that I kept doing what we did in our program. Well, let me start with a bit of a personal story. So I actually started my higher education as a sociologist. So my first degree that I got was a bachelor in sociology. And during my studies, Dr. Khvatskiy had 2 courses, I think, but well, the first course was on time series analysis. And I was kind of amazed at how different it was, because usually, at least in Russia, what sociologists do is that they just read books and work with theories and kind of disconnect with the real world and real data that exists out there. And then maybe somewhere in the end of their research, we call this armchair sociology. In the end of all their armchair sociology stage, sometimes some small bit of data comes into play and proves whatever they were talking about for like most of the research, most of the paper. Now, there is also a great school of data science in Russia, actually. We have a lot of great data scientists and they work all over the world. But again, the way they're taught is that they are taught a lot of mathematics and a lot of methods on how to work with data, all of the ins and outs of some analytical algorithms and optimization methods and so on, how to work with GPUs. And this is all very important. But again, they have a problem with applying that skills to the real world because they, in contrast or in mirror image to our sociologists, they have a really little understanding of theory and of how to actually get the data from the real world and work with it. And since I'm honored in data science, I have been kind of immersed in that environment as well. But Dr. Khvatskiy's course was structured differently in the sense that it kind of combined both the theoretical understanding of what data is. It was on time series, so we started, I think, the first example that we were shown was the arms race on the of the USSR and the US. And we were kind of analyzing these 2 things. And yeah, we were kind of looking at our theoretical understanding, or at least our common sense understanding of what these 2 things are and how they were connected. And then we were actually trying to find the right method to somehow either conclude whether they are connected or not. And yeah, this was kind of amazing for me. Now, after that, I have actually joined the master's program that was headed by Dr. Khvatskiy. I was, I think, in the 2nd cohort. So yeah, I was one of the first people to get in there. And this program was actually built around this type of approach. So we were, first of all, we were taught to identify real problems that exist in the real world, either in some academic literature or in in the mind of our commercial clients. And then we were taught to find the right tool, to apply it properly, and to actually arrive at a solution that is somehow actionable in the real world. And after studying there for 2 years and graduating, I have actually went back to sociology. Now I am getting my PhD in sociology, and the gist of my PhD is actually trying to bring at least part of this approach to social sciences and apply this type of approach there. Now let's talk about the programs themselves. So this webinar is for the Master of Data Network Analytics program, but there are actually two. The first is Master of Applied Statistics with Network Analysis program. We call it MDNA for short. It's our offline program that we do on our Pokrovka campus in Moscow. It's a beautiful building. You should all come there. And the second program is the Master of Data Network Analytics program, which we do online in Coursera on the Coursera platform with partnership with Coursera. Yeah, this is if you want your education to be more flexible, more online. The lectures will be pre-recorded, but there will also be synchronous live webinars if you want to, if you want some more face-to-face contact with your professors. Now, content-wise, these two programs are very similar. So I'm not going to go into the differences between them. We say that they're mirror images of each other. And actually, talking about the content, our programs are based on pretty much two very important principles. The first is that we teach from the applied perspective, and we use this problem-oriented approach, as I already said. So we teach not theory, not just theory without any relation to the real world or data or whatever is there, but and we do not only teach mathematics without any without any knowledge how to apply it, but we try to combine those two things. So we teach to identify problems, we teach to actually find the right tools to solve these problems, and then to actually use these tools properly. And this is where all of our mathematical knowledge comes in, to use these tools properly to actually arrive at a solution that is both understandable to people who are not analysts, and it's also actionable if it's like for a business analytics project that you can actually act upon to improve your business. And the second most important part of our program is our emphasis on network analysis. And this is important because most classical statistical methods, they assume that the data are independent, identically distributed. Even most deep learning methods, they are non-parametric. They do not rely on the data being distributed in some way, but they still rely on individual data points being independent. And this assumption is, well, not always true. So for example, if you participate in a survey and some of your friends participate in a survey, then obviously this assumption of independence will not hold between you just because you talk with each other, and surely your opinions on things like politics or maybe whatever else are somehow dependent on each other. And the network analysis and network-centered approaches, they allow us to explicitly model these dependencies in our data sets, and actually to base even our conclusions on the structure of these dependencies. These are very powerful tools, especially when applied to things like organizational studies, where you can somehow explicitly map communication between different people. Now, I should also say that this kind of problem-oriented approach is also spilled over to our study process. And I should say that on our program, there will not be that much exams, but most of the studies will be centered around learning some new method and then doing a small research project to actually demonstrate that you know what you learned. But again, this will be a very small project, but it will be a research project from start to finish. So you'll have to identify a problem, then formulate some theory, and then actually prove it or disprove it, or work with it using real-world data that you probably collect yourself and the methods you have learned on the course, during the course. And yeah, your final thesis, it'll be almost exactly the same. You'll have to do a research project and then defend it. Now, I want to make a joke about our program. Is that we have this in joke between each other that we sometimes teach telepathy. And that's because, especially when working in business consulting, and we actually have a business consulting course in both of the programs where you work with real clients. And when working with these real clients, it's sometimes very hard to actually understand what they mean when they come to you and start talking about some problem that they have. Just because what is happening in reality, what's happening in their heads, and what's coming out of their mouth are three different things. And sometimes you just have to actually learn to understand them. And this is another skill that you can acquire in our program if you want. This is actually what makes you a really valuable analyst, I think, because there are not that much people who have that skill. Now, let's actually start with our examples. I think that in social science, one of the most important things is to actually identify the social issues that exist in some social group or in our society in general. And this can be actually a very hard thing to do, especially if you're entering some new field or some closed community. Now, before social networks and before internet, this was done by anthropologists. They were actually working very hard on that. They were somehow getting there, and sometimes they were actually marrying people who are part of this community in order to get access to that. And they were writing big books about this. They're actually very interesting to read. But with the advent of internet and social network websites, we now have actually much more open data to work with. And of course, there are like closed groups and stuff like that, but still, there is now much more data available. And what you can get from those groups and those pages are actually texts of individual posts. And to actually convert them about knowledge on what issues exist there, out there in this group or in our society in general, or in connection with some brand under our eye that we analyze, there is this tool that is called sentiment analysis. And it actually allows us to identify which posts, which texts, they have negative emotions in them, or they have positive emotions in them, and how they are connected with whatever the content of this document or this post, this text is. Now, for sentiment analysis, there are actually many methods. There are very complex models that are based on deep learning and neural networks with attention mechanisms. And this is all very well and good. But there is this method that was actually one of the first that was ever applied in text analysis for sentiment analysis. And it's called lexicon-based or dictionary-based sentiment analysis. So it's based on using what is called a lexicon or a dictionary. And I have an example of such a dictionary here. This comes from the so-called Vader project, where they actually go and create those dictionaries. So let's load this, and I'll tell you more about what it is once we can look at it. So let's actually sort them by polarity and start with the more positive ones. So this dictionary, I'm not sure how well you can see it, but the font is quite small. But if you look in here, there are words, and these words describe some activities, and some feelings that we might have. And for each word, there is this column that says polarity. And this polarity describes pretty much how much of a positive or a negative emotion does this word describe. So here the word is euphoria. It obviously describes positive emotion, and its rating is 3.3. So it's fairly positive. It's actually very positive. Now, there are many ways to come up with these ratings, but in here, actually, a bunch of experts all got together, and they have read texts from social networks, and they have just coded them on how positive or negative they are. So here are the most positive words, and they describe things like ecstasy, euphoria, sweetheart, and happiness, love, and things like that. And for negative words, there are other words that describe activities and things and feelings that are not really welcome in our modern society. Now, if you actually sort by word, you can see here that there are some smiley faces and things like that. And this is because this corpus was actually gathered for social network, and it is geared towards social network analysis, analysis of data derived from social networks, which is actually what we're doing here. Now, while this method is primitive, what makes it really useful for analysis, especially in like business situations, is because you can easily alter those dictionaries for your own purposes. So, for example, here, it's just we can start with this dictionary and we can change it. And this is very powerful because, for example, if we are analyzing movie reviews, and especially reviews for action movies or thrillers, there would be this something like the word unpredictable would be a very good characteristic for a thriller or an action movie. I mean, you don't want the plot of such a movie to be predictable. But if we are talking about cars and analyzing car reviews, I don't really drive a car, but I am sure that you would want your car to be predictable, and unpredictable would not be a good characteristic of a car. So, and all these differences, these contextual differences, they can actually be included inside these dictionaries, so they can be modified. We are just using some lexicon that I got off the internet for analysis of social network data. But again, if you're going to work with some very concrete problem for some very concrete client, that can be done. Now, for our data set, I've actually decided to go with tweets of Elon Musk. I have downloaded all the tweets from Elon Musk for the last 2.5 years, from the start of 2019 and up to this day. I think there is some 3-day lag between when I downloaded the data and when I'm using it. But yeah, it's not that much. Now, to download the data, I've used this program. Let's actually go here. It's called Twint. It's very easy to use. It requires you to type some commands into the command prompt, but again, it's completely free. It's completely open source. It has a lot of help here on how to use it. It actually has a full wiki. Oh, and here is actually the page of the lexicon with the raw data. But yeah, if you want to see me using this program, you can actually watch our previous webinar on what you can do with data analysis. I've actually shown it running there. So let's load our data into R. Now, there is actually the code to load all of this data and to pre-process and to kind of separate it into columns and something like that. But it's not very efficient, so I'm not going to run it for the sake of time. I'm just going to actually read some of the already pre-computed data. So here is the data. It's in our variables called Tweetdata. Let's look at it. So you can see that for each of the tweets, we have its ID, and this will come into use later. We have the date and time when the tweet was published, and we have the text of the tweet. And these weird characters are emojis that were destroyed by the R reading them, because R on Windows does not work that well with Unicode. But yeah, all of the data that we need, all of the English words, all of the Latin text is here. Now, let's actually go and do something with it. So I think that Dr. Kuskova kind of already touched on this, and why text analysis took that long of a time to get into prominence and take its place among all of the other great data analytic methods. It's because text as a data is a very hard thing to analyze, actually. They are sequences of data. They are all of different lengths. They words in a language like English, it's less visible, but in languages like Russian is a fusional language. Words change their forms based on the rule in a sentence. So actually getting a computer to understand these texts and somehow work with it, it's very hard. So different types of analysis for text data were invented. One of them is called bag of word analysis, and this is what we are actually going to do today. Now, in order to prepare for this type of analysis, and let's start actually running code, what we need to do is we actually need to get the computer to understand the language And for each of the words in the text, in whichever form they might be, to put them in all the same standard form, the same form that is in the dictionary, and it's called the dictionary form. Now, again, it can be very hard. Human languages, natural languages are actually sometimes can be very hard to understand for humans. But some people have worked very hard and they have designed these language models that allow computers to actually understand these texts and do this text processing relatively well. And here's the code that does this. It pretty much loads the one of such models. This is a freely available model for the English language. Again, all of the things that I'm using here, all of the packages are open source and freely available. So I think I have a question in the chat, but I can't read it right now. So now, after we load the model, we can actually run this. But again, it takes time. These models are computationally complex. So let's just load our lemmatized data just from a file that I have computed before. And it has been loaded. So let's look at our data that has been lemmatized, so processed. And you can see here that there are still IDs of our tweets, but now for each of these tweets, we have one word per line. And for each word, we have its form as it appears in the text. So its token, its dictionary form. So it's lemma. And you can see here that, for example, the word test here was in a plural form, but here it is in its singular form, it's in dictionary form. And then some additional information, such as the part of speech for the word, for example, whether it's a noun or an adjective or something that it could not describe. So, could not determine the part of speech. Now, as you can see here, this data is kind of what we call dirty. So it contains a lot of things that are not really useful for our analysis. So it contains words like we, which for types of analysis that do not actually use word orders, they are not really useful. We have words, we have symbols here, we have usernames, we probably have a hashtag somewhere, but this is actually not a really good way to represent the text data for further analysis. So let's start by cleaning it up. And this is actually all of the code that you need to clean up the text data. So you start with the data that we have with this text data lemmatized. So I have just showed you this data. And then you remove some words from there that do not make any sense for our analysis. They're called stop words, and they are words like we, like and, conjunctions, pronouns, stuff like that. Then we will also remove user mentions and hashtags. They are not really useful for us, although counting different hashtags can also be done, but we're not just doing it today. We are removing links. We are removing anything that's not an English word. And this is because sometimes there is a multilingual text in these tweets, and our lexicon is really only designed to analyze text in English language. And we also remove some of the parts of speech that are not really useful to us, such as punctuations, symbols, numerals, and also words without where the model has failed to determine the actual part of speech. So again, this will remove stuff like usernames and neologisms. And then we also remove words that are too short to remove things like abbreviations. And this is just something I usually do in analyzing text. It helps for Russian. I think it will also help with English text. And then we also do some data wrangling just to make our data easier to work with and more readable. Let's run this code. This will actually run fairly fast, and we'll create another data set. You can see how much smaller it is. So we have removed like 75% of our data. And if we look at this, it will be much smaller. So it will be just the ID of a tweet, and then one word per line in its dictionary form. So let's actually close out of this all. Now, let's actually run our sentiment analysis on our preprocessed data. So, and the procedure for running sentiment analysis with a lexicon is actually very easy. So what you do, you start with these pre-processed tweets, so with our clean text data. We then, for each word that is in the lexicon, we create a new column in this data, and we add the polarity of the word that is specified in the lexicon. Then for all words that are not in the lexicon, we just assume polarity of 0. This is just an assumption I make. It usually works. You can make your own. You can, for example, say that all of the words that are not positive are negative. I just assume that all of the words that are not positive or negative are neutral. And then we do a little bit of data wrangling. Now we group our data by IDs, and for each of these IDs, we just combine the sum of all the polarities of all the individual words. This is kind of a crude method. What we also compute is the number of these words. Now, this is kind of a crude method, but it usually works. You can do other things. You can combine, for example, an average polarity. You can combine the median polarity. You can use whatever else you want, but it's just usually that sum is used. And it works fairly well in practice. And then we actually take our raw data set with the texts of the tweets and the date times and the rest of our data, and then we just join them. And we also compute this another column that is actually a representation of a binary or ternary sentiment. So whether a tweet is in general is positive or negative without the actual numerical value. Let's run this analysis, and we'll also run very fast. And it has created this another data frame. It's called Tweetdataset. So if we look at it, what we will see is that there is now the ID, the date time, they're all the same. But now for each tweet, we have its sentiment, so its polarity and the number of words. And now the more negative this number is, it indicates that the more negative this tweet is in its emotional content, and the more positive this number is, this tweet is more more positive in its emotional content. And if we look at some random positive tweets, so this is positive, this is 2.4, you can see that Elon has congratulated someone on something. And if you look at a random negative tweet here, you'll see that it's some comment on interest rates somewhere, which is also kind of not very positive. We can actually just sort them by sentiment to find the most negative tweets, and here he's talking about some Tesla owners who are conspiracy theorists, or that they are not conspiracy theorists, and you can actually see that it's negative. And for some other tweets, you can also see that he's talking about someone's grief. So yeah, that's kind of so these numbers kind of actually corresponding to the actual content of the tweet, at least as I see. Now, if we try to look at the most positive tweets, you can see that he says things like that engineering is awesome and someone did an awesome job and something like that. Now I'm also having questions. Let me look at them. Yes, we are going to get the recording on this webinar. It's going to be posted on our YouTube channel. I'm also going to probably post the code somewhere. Let's look at the chat.
Oh. I will send the links right now. So
yeah, I guess the time is right. Mm-hmm. So now this sentiment is actually indicates the meaning of the tweet, just as we have seen, but it's just a number. So I can work with it as we work with numbers. I think that the first thing I usually do when analyzing text is just look at the histogram for kind of a smoke test. Now this illustration is going to be very crude, but as you can see that most of the tweets are neutral, so there it's 0, but then there are some negative and some positive tweets, and you can see that this distribution is kind of more tilted towards positivity, probably because it's Twitter. Now let's remove this plot. I don't like it. Now, for each of these tweets, let me actually open the dataset again. Now, for each of these tweets, we actually have its date when it was published. So I think that a really cool thing to look at would be for all the different months of the year, compute their average sentiment for all the data we have, and to see which months are the most positive and which ones are the most negative. So again, this is very easy. We start with our tweet data. We then add a column to it that just just contains the month, so it's actually just a word. We then group our data by the month, and we then compute the mean sentiment or the average sentiment for each of these months. And then we actually use ggplot. It's a package that's fairly easy to use to create a nice plot of our sentiment for each month. Let's run this. This will run very fast. So if we look at this plot, let me make it bigger. So if you look at the plot, we can see that some of our months are more positive than others. For example, the month of December is the most positive, and this is probably because of Christmas. And there are some other spikes in positivity in June and February, and I'm not sure why. But I believe that it kind of correlates to some cycle of holidays that exists in the US. Or maybe it correlates to SpaceX launches. I don't know. But yeah, this is one type of analysis we can do. And again, we can kind of group this sentiment not by months, but by weeks or by days if you have a lot of data, and then try to see which events in the real world actually influence this type of influence the sentiment of the tweets. And this is actually kind of ties in really well to the time series course, the first course of Dr. Kuskova that I actually had. Now, since we have the words in the lexicon, we can actually try to use them to identify the issues that Elon Musk actually has. So what we do here is we actually redo a part of our sentiment analysis. So we start with individual words, and then for each of these individual words, we actually add our sentiment. But what we do next is that we actually count the most popular positive and negative words, and then we keep top 15 most positive and top 15 most negative words, most often used positive and negative words. So let's run this code, and then again we will show it on the plot so it's easier to see and interpret. So you can see from this plot that the most often used negative words are stuff like crazy, tough, deaf, and this is probably describing the last 2 years that we've had with all the COVID pandemic going on, and also stuff like critical and difficult, which is probably connected to some engineering issues at SpaceX or Tesla. And for the most positive words, you can see that there is words such as improve, progress, awesome, amazing, and these are words that are, in general, we consider very good and describing good things. And the word energy, it's probably in connection to something like solar energy and issues like that. Now, since we're using a pre-made lexicon that was kind of pre-designed, the words in the lexicon, they kind of limit us actually. So for example, if some words were mentioned in a negative context, they would certainly describe some issue that is happening. But if they're not in the lexicon, we will just not see it. They will be removed since we only kept words that are in the lexicon. So we can do another thing. We can actually remove the words that are not in our lexicon, that are in a lexicon. So we only keep words that we do not know the sentiment of. But then we can see, and we can kind of plot and show it on a plot, which words are most often seen in a negative context, in negative tweets, and the words that are most often seen in positive tweets. And this is actually very powerful. So let's run this, and let's take a look. So, for example, here, the more the bar of a word is to the left, the more negative it is. And the more to the right, the bar of each of the plots on this plot is of each of the words, the more often it's seen in a positive context in relation to how often it's seen in the negative context. Let's actually, okay. So you can see that things like accelerate and testing and improvements, although this is not a really good word, but it's spelled wrong, but still. And the names of some blogs and other projects such as OpenAI, they're usually actually mentioned in a positive context, and this would be kind of expected, especially from a guy interested in tech and technology such as Elon Musk and in technological progress. And rapid improvement is kind of a positive thing for him and for actually all of us. Now, if we look at the words that are meant and are most often mentioned in the negative context, you can see that these were words like corona and elderly, and actually the word labor, which I don't really like being mentioned in the negative context, but still, it's probably describing whatever. These words, they're more certainly describing the current pandemic, and this word is probably describing his quarrels with labor movements at these factories. So again, you can kind of actually start to look at some societal issues, even using this simple analysis that just took us, 108 lines of code. Now, these two illustrations, they're actually kind of really easy to read, and they look good, I would say, but they do not really look good as a first slide of our presentation or or in a blog post, unless you're like a really serious blogger. Actually, a nice way to visualize different words and the results of text analysis is by making a word cloud. So in R, there is a package to do this, and again, it's very easy to use. It's just not that much lines. Let's run the code that does this, and as you can see, it will actually count the. It will do exactly the same as shown here. So it will count the most frequently used positive and negative words and show them. But here it will do it in this word cloud form, which is, I think, easier to understand. It looks better in like a presentation or something. So here I am. Let me actually switch back to the presentation. So here I'm done with the first case, but let's now move on to the second. And the second is that when actually analyzing this type of text data, it's sometimes being very important, and sometimes is very important, to separate opinion statements, so whether someone believes something or whether they like or do not like something, from actual factual reports. And this is very important, for example, when doing brand analytics, because the usual sentiment analysis, the simple sentiment analysis, it might help you identify some issues, but by looking at whether these issues and these words, positive or negative, actually appear in more factual context or in a more of an opinion context, it might be much more, insightful, especially if you're doing things like business analytics, to somehow, it can generate much more insights on how to work with the audience in this case. And here is actually where we come to one of the parts of our program and identifying the right tool. I actually did not find a package for R that can do this. Maybe there is one, but I just didn't find one. So I actually turned to Python to do this. Let me actually open up my Python code. And here it is. The Python package is called TextBlob. Again, it's free and open source. It's fairly easy to use. It is designed to make text analysis easy. So let's load it. It'll take some time. Yeah, it's loaded. Now, let's load our tweets and look at them. And you can see that they have loaded much more faster into Python than into R. And this is just my actual experience using these two languages. And we can again look at them. They're in a slightly different format. In R, they were in a table. Here they are in this less structured format. They are in a list of dictionaries, but still we have the same type of information, the ID of a tweet and the text of a tweet. And here, since we are in a browser, emojis display properly. For the analysis we are running here, we do not need the dates, so I just did not load them. I just ignored them. Now we can actually run the sentiment analysis on our tweets, and this code is very easy. It also runs very fast. What it does here is it just, for all of the text, it just takes each text, runs it through the library, and then extracts the polarity and the measure of polarity for each tweet, and the measure of subjectivity for this tweet. And we'll talk about this a little bit later, what do these numbers mean. We can again look at our tweets that now have already been analyzed. And you can see that the now for each tweet we have its polarity and its subjectivity. So 2 new values added. Can actually convert them into a more tabular form, and we can write them to disk. And we are done with Python. We have we have computed our data. We have run it through our analysis, and we have kind of saved it to the disk to actually work with it using some other tool. And again, we're taking the right tool for the job, because I think that doing visualizations with Python is kind of akin to torture. So I will not be doing that. I will be using R again. And let's actually, I have deleted all the data. Let's actually repeat our lexicon back. So again, we will be using the same libraries that we have used before for our lexicon-based sentiment analysis. And again, we will start with our tweets that are lemmatized and preprocessed. But now, instead of actually doing all of this analysis, finding the polarity of each word and then somehow attaching this polarity to each of our words in the corpus and finding the sum, we are not going to do that. We're actually going to use the file that we have computed using Python. So our reprocessed tweets CSV, and we're actually going to load it into R, and we're going to take a look at it. And since the Python library, now let's take a look at it. I will show you some things. So now for each of the tweets, we have, again, its ID, its text. We do not have the date yet, although we can just use a simple join to add the date. And now we have the two more measures. So the polarity, and this is what I've been actually calling the sentiment in our previous section. So this is how positive or how negative each tweet is. This is on a range from -0 to from -1 to +1. And again, the more negative it is, the kind of the more negative of emotion does the tweet somehow convey. And the more positive it is, the more positive is the emotion of the tweet. Now the subjectivity measure it's on the range from 0 to 1. And if it is 1, it's just a statement of opinion. And so the more it is, it's more subjective it is. If it's 1, it's just an opinion statement. And if it is 0, it's a factual statement. And let's actually take a look at our tweets, and you can see that sometimes the algorithm does some weird things. But for example, if we look at our most subjective tweets, there will be some things. They will be saying things like "nice" and "Happy 4th of July to all," and it's just statement of opinions on some events. And again, we can look at the polarity. So the here is the "congrats boring company team," but that's probably because the word "boring" isn't there. It's still hard for computers and even for humans to understand sarcasm these days. But again, if you look at most, the worst tweets here, you can see that describing things that are insane and stuff like that, and annoying. So, definitely not positive things. And if we look at the most positive tweets here, you can see that things like, again, awesome, impressive, people, there is, NASA is awesome, and stuff like that. So, the good things in life. Now, we can, again, as a smoke test, make a histogram. And again, I don't like this picture, but you can see that the previous histogram that we had and they are all fairly similar, with like this bigger tail to the right. So yeah. Now, one more kind of these technical illustrations that I actually kind of liked. I just did it as a test when I was preparing the webinar, but I decided to keep it because it's, I think, really interesting to look at. If we plot the subjectivity of tweets, the subjectivity of a tweet on the x-axis and its polarity on the y-axis, we'll see that it kind of, the more subjective the tweet is, the more spread out is its polarity. And for more objective tweets, they're usually more, they usually have less emotion in them, and even if they're negative, they're only slightly negative or slightly positive. And if they are more subjective, they will have a wider range of emotion from very positive to very negative, and so on. Now, if we actually look at here, we have these two columns, and this is again positive, negative, or neutral. So less than 0, equal to 0, or more than 0. If it's more than 0, it's positive. If it's equal to 0, it's neutral. If it's less than 0, it's negative. And this binary subjectivity, and here I just came up with a threshold. And if the value of subjectivity is more than 0.5, it will be considered subjective. And if we go here, so for example, if we try to find some objective tweets, you can see that tweets with like value of subjectivity of something like 0.2, they are considered objective. And we can actually do the same type of analysis in here. I have discovered that I get much more meaningful results when removing the words that are present in the lexicon still. So let's run this. And again, this is us finding the words that are most present in a negative and in a positive context. And you can see that things like priority, motor, and bandwidth in America are usually mentioned in positive context, which probably says something about the data that we analyze, especially the word America, because we're analyzing the data of an American citizen. And other things such as, again, corona, something about the vaccine, something about some streaks of something, they are usually mentioned in negative context. And again, with all of the pandemic going on, the word corona here actually really makes sense. And these vaccines are probably mentioned in posts about there not being enough. So again, it makes sense. Now we can actually make a very similar plot for the differences between objective and subjective tweets, and we're using this binary classification I came up with. I've just told you about it. So if this value of subjectivity is more than 0.5, it is considered subjective, otherwise subjective. So let's run this, and it'll still say positive, negative log odds here, but this is actually subjective, objective log odds. So the more to the left, the more objective the word is. So for example, for things like vacuum and technically, or external and plain, Elon is probably describing some technical aspects of whatever he's doing, probably of rocketry. And for and in more, kind of subjective tweets, the more emotional and the more opinionated ones, he's probably describing things. He's probably talking about things like, something that he believes in, like the words absolutely, and some revolutions. He probably shares his political opinions, and I'm not actually going to go into political analysis, but yeah, probably some political opinions, something about something that's sensitive, and his emotions towards different communities of Tesla users. So again, this kind of all makes sense. So I'm actually done with the cases. Let's go back to our presentation. And I think that will make it full screen. And how is it? Yeah, like that. Oh. So actually, I have just barely scratched the surface, not only of text analysis, but of data analysis in general. So yeah, if you want to learn more, you should probably join our program. In our program, we have a great team of instructors and our fellow professors. They're all rock stars of data analysis. So I have showed you some of the packages. I do not think that I have shown you any of the packages that they themselves developed, but still, Janis Demshar they have actually worked a lot in advancing data analysis and developing data analytic software. So for example, Yanes Demshar, he's the developer of data analysis tool Orange. You have probably seen it in our previous webinar where Dr. Zaitsev used it to do some political analysis. Eric Strumbel is currently one of the world's leading scientists in Bayesian data analysis, and he's actually one of the developers of an open source package called STAN. That is one of the most popular toolkits for Bayesian analysis. And other professors that are not in this picture, they include Vladimir Botagel, who is the developer of a network analysis program PAYEK. It's a network analysis toolkit that allows for a relatively easy analysis of extremely large networks with billions of nodes. And it's all native code, so it runs extremely fast. So yeah, we got a very big, very famous team of experts here that are working on developing our program and are making this a reality. Now, if you actually want to try yourself in data analysis, probably before you join our program, which you should, we have a network analytics for business specialization, and it includes courses in how to actually work with data, how to use it. We have a course in introductory course to network analysis, which is which, as I said before, will allow you to model dependencies that exist within your data. We have an introduction to text mining course, which I was a part of a team that made it, and it actually touches on these topics that I have described here, but it goes into them in much more depth. It actually describes why do we do things that I've done here, such as text preprocessing, and why do we use UDPipe, how does it work, stuff like that. And it also covers stuff like topic modeling and other text analytic topics that I did not even touch here because they deserve their own courses actually. And we also have the business analytics course where you'll actually learn how to apply all of this data analytic goodness that you have learned here in practice, and how to actually present your results to your clients, how to make them actually actionable, and how to make them easy to understand, which is an extremely important extremely important aspect of working with data, because a lot of very good research, it just gets destroyed during this last step in its cycle, the presentation step. So if you want to find more info about our specialization, the link is here. It's on Coursera. All of the courses can be audited for free. So if you just want to watch them, if you want to get the certificate, you'll have to pay though. But financial aid from Coursera is available. It's the usual thing. Now, you can contact us on using these emails. If you want to contact the program in general, you can use this email. You can also use it if you want to apply, which you should. Yeah, so I guess I still have something like 5 minutes left. So if you have some questions in the chat or in the Q&A section, then I'll be happy to answer them. Yeah, let me stop sharing my screen now. Just open some good looking slide. Yeah.
That's a very good looking slide, Grish. Thank you. Well, that was actually very interesting. And I was waiting for some questions, but there were none. Anna sent links to our Telegram chat and to our future webinar. We hope you join us. Hopefully somebody might have a question about anything that Grigoriy said. If not, please feel free to write to us. You are welcome to write to any of the email addresses that are listed for our program. You can also contact us via chat on our Facebook page and via any other channel, including Telegram channel that we have shared with you. Thank you for being with us. We know that you do have a choice of where to spend this lovely summer evening, and we appreciate that you came to listen to Grigoriy's presentation. We hope to see you in our future webinars and maybe even as students in our program. And I want to thank Grigoriy for this excellent presentation. And I hope that you will see more of his presentations in the future because he is actually one of the instructors working in our program and in our laboratory. Grisha, thank you very much. And thanks
Thank you.
again, everyone, for being here. We'll see you again very soon. Goodbye.
Yeah, thank you. Goodbye.
Thank you. Goodbye.